I'm going to show you in depth what's inside the Tesla gateway and see how the system's put together. This is what the box looks like, and then what it looks like inside. On the left is the main computer. It has an Ethernet port on the front which goes to the LAN. And if we have a look at the network activity that goes through there, we can see the OUI of that interface. So if we look that up in the Wireshark OUI lookup, we find that it's a Win Systems OUI. So if we do a bit of a search on Win Systems, we find out that they make small industrial computers. And that makes sense since that's what the purpose of this one is. Up the top of the unit is a device which is an energy meter. Now this is made by a company called Neurio, and if you go to their website you can get a fair bit of information about how this works, and it even has the API there. Now the way they're marketing this Neurio unit is that it allows you to put one in your home and then you can connect up to it and see how much energy your various appliances use. The way it's used in this Powerwall is with a couple of CT clamps. One of them measures the site load and the other goes out to the meter box and clips around where the solar feeds into that meter box, so it can measure the solar energy coming into the system. Now when the Neurio device first powers up, it transmits 802.11 beacons as though it's an AP. This is because according to the website documentation for it, if you were to have one of them on its own, you can connect to it with a Wi-Fi client and start reading energy data. Now in this Powerwall configuration, it becomes a Wi-Fi client to the main computer. We can see it doing some probe requests to the TEG SSID, which is the Powerwall computer. The OUI of Redpine signals is what responds to the probe requests. Of course, we can look that up as well and see that it's just some wireless chipset vendor, and the computer obviously uses that for its Wi-Fi interface, so there's nothing too special about that. Now we see the standard 802.11 association and the four-way handshake. It's just a pre-shared key with the serial number as the passphrase. Now that we've captured the four-way handshake though, and we know the passphrase, we can decrypt this data in Wireshark. I've made another video on how to do that, so check that one out if you're interested. Now we can see the actual network traffic between these two devices, which starts off with the simple assigning of a network address via DHCP to the Neurio meter. From there on, the only real thing going between them is TLS data on port 443, which is what the Neurio manual says it communicates on, so that makes sense. Now here's an example of something that can go wrong. In the setup wizard, the meters section should look like this, a nice green successful connected message. Now if someone does a DAuth attack on this, there will instead be a red unable to read meter message, and the system won't work. Being prone to 802.11 denial of service attacks is the first problem. Following on from that though, is that after a DAuth attack has occurred, the Neurio meter never reassociates, which is bad. The only way to get it running again is to cycle power to it with this connector. Now before realizing that this is what was happening, the electrician installed an extra cable between the computer and the Neurio meter, which is an RS485 interface. This theoretically was supposed to prevent any such loss of comms between the units, but after testing another DAuth attack with the cable in place, the system is still vulnerable to failing. Initially I thought that the access point of the computer was simply so that the installer could connect to the Wi-Fi of it, do the setup, and that was it. What I didn't realize at the time was that there was another device inside, this Neurio thing, which also relied on 802.11 Wi-Fi to connect to the computer. So to prevent anyone from reading the serial number and then connecting their phone to my system, I marked the AP as a rogue AP with my Aruba wireless system. That makes it unable to connect to, but of course had the side effect of not letting the Neurio meter connect to it either. Needless to say, I don't have rogue AP containment on it anymore. Of course, it's still vulnerable to someone doing a DAuth on the Neurio meter. Alright, if you connect to the IP address of the computer in this gateway from your computer on the same network, you'll see a pretty little animation of what power is flowing from where. If we do a network packet capture on this, we see it's just simple HTTP on port 80. Roughly every 30 seconds, there are a couple of requests from the browser to the gateway to get the meter information. Now you could write your own program to get these values more often if you like, but that's just how this interface does it. The information that it returns is pretty comprehensive. The four areas of data are the site, which indicates the grid, the load, which is the house, the solar, and the battery. There's plenty of info there if you want to make your own program to track whatever you're interested in. Now, since this device wants to be in contact with Tesla, I've decided to block it at the firewall. I made a rule in pfSense to reject any attempt it has of reaching the outside world. For now, I'll disable this blocking rule to show you that it connects to Tesla. The main reason it connects to Tesla is so that you can use the mobile app to monitor your usage. The mobile app links up to Tesla and then reads your data that also gets sent up to Tesla from the Powerwall. That might be fine for the masses, but I don't really see the need for Tesla to have all my power usage data when I can connect to my house anyway and see it for myself. So that's the reason I block it from reaching the internet. The site master API link is what passes back whether it's connected to Tesla or not. Another API link is to show the percentage of battery charge. There's also a grid status link. This one returns the state of connection to the grid. If the mains goes down, or is turned off as in this demo, you will hear that click in the gateway, which is the system shutting off the power to the grid so it doesn't feed back into the grid that is down. If you request the grid status during this time, it'll show System Island active, which means you're on your own. When the grid comes back to life, the returned value will briefly be System Transition to Grid, which indicates that it knows the grid is back and is getting ready to reconnect. Then after a moment, you'll hear the click again, and then the system returns to being grid connected as normal. The main problem I have with devices and appliances that demand internet connectivity is that you put them on your trusted network and they will create a link to some other network, namely the company you bought it from. And by doing that, that enables the remote network, the people at the other end, to get into your network. Now, that will bypass any firewall you've got because the connection came from inside your network, so it's theoretically trusted. But once you've got that connection going out, the other end can also get back in. So you've just bypassed all the security you had. Now, the way I get around this is I put those devices on a separate VLAN, and that VLAN has no connectivity to my trusted network. Now, I can do that because I've got some fancy switches, but most consumer-grade products aren't able to do that. And most consumers aren't really that savvy enough to create separate VLANs and block them off of firewalls and things. So it is a big problem, and it's probably not one that's going to go away because people want things to work and they want it simple, so they'll just do what they've been told. But they don't really realise how they're opening up their network to vulnerabilities. Other than that, this system, the Powerwall, and together with the solar, is pretty fantastic. Like, the battery capacity is huge, easily runs this place, and I'm pretty happy with it. So I'm even happier that I can kill its internet connectivity and still use it, and still connect. I can connect to it from the internet, so I'm happy with that all around.